One question that comes up quite frequently is how to model 3D printable threads in Autodesk Inventor. If you go to the Autodesk Apps Store at apps.autodesk.com and go to the Inventor category, there is this thread modeler which will help you convert threaded holes. But I want to show you a way that perhaps to have more functionality or user controlled functionality, considering that 3D printed processes aren't necessarily very precise. And so I want to show you how to have some control in creating your own threads with a desired amount of clearance. So first let's look at how we might use this tool, and then I'll show you how to create your own tool. And so I have a standard part here, but we're going to use a little trick by temporarily converting this into a sheet metal part. And so I'll go to the Environments tab and I'll do Convert to Sheet Metal, and notice I can always go back and I can convert that back to a standard part. And so once I have converted this to a sheet metal part, I can then use the punch tools to place holes that I have made or features that I've made myself. So I have 4 sketch points around the outside, and I'm going to go to the punch tool and I'll tell it to use this metric modeled thread. And so we see that it finds those 4 sketch points and it starts to place a thread in those sketch points. I'll go to the size, and I have placed a list of sizes here, and I'm going to use this M6 size. And then for the thread length, I'm going to do, say, a distance of 20 millimeters. For the pitch, I'll leave that on a pitch of 1 millimeter. And then for the hole depth, I'm going to go a distance of 25 millimeters. It's important to make the hole depth at least as great as the thread length, and it really should do it a little bit greater. Now here's the important part of this too, is that I can put in a clearance value in here, considering that 3D printed processes aren't very precise, and we can adjust that clearance after printing a part to see whether we need to loosen that clearance or tighten that clearance. And so I'm going to say finish to this, and if we zoom in here, we see that we have our 3D our modeled threads in the part. And I'm going to do this a couple more times. So that's selected as many sketch points as I have in my sketch. It will automatically select those. In this one I have 1 sketch point. I'll do that again. So I'll do the punch tool and I'll go back to my punch box and I'll go to the size. And so for this one I'm going to do as an M4, and for the thread length I'll do that. You can type in a distance here. I'm going to put in a distance of 20 again, and for the pitch I'm going to change this to 0.7, and for the hole depth I'm going to tell this to, let's say, 50. And then I can adjust that clearance if I like. Now I can edit that hole depth after the fact, so let's just go ahead and accept this. And one thing about doing helical threads is you should save often, because it becomes computationally really expensive to have a lot of threads in your part. So we see that this hole doesn't go all the way through, or actually it did go all the way through. If I wanted to change that depth though, I could right click and I could edit that feature, and I could change these dimensions as needed. So I've got what I want on that. I'm going to do a circular pattern now of this. So I'll do a circular pattern. I'll select that feature and I'm going to pattern around this hole, and I'll say I want 4 copies of that, and I'll say OK to that. Notice also that I have a lead in or chamfer on the hole. Let's do one more hole, and so I have a boss over here on the side, and the key is having a center point any place that you want to place a punch, a sketch center point. And so I'll go to the sheet metal tools, I'll do punch, and I'll select my punch tool, and this time I'm going to do an M3, so I'll select a size 3, and for the pitch I'll do a pitch of 0.5, and for the hole depth let's put that to 30, and for the thread size let's do that as 15. Not for the, I want to put that back on 3 for the thread length, not the thread size. I'll put that on 15. And so we see that our hole put over into that face. So let's look at how to create these punch tools, and you can create any punch tool that you would like. I almost forgot to mention to after you place your punches, go to environments and convert it back to a standard part, so that you still have your standard tools even if you're in sheet metal, but you might be confused by that if you don't go back to the convert it to a standard part. Alright, so I'm going to start a new sheet metal part. So I'll do File and I'll do New, and I'm going to select a sheet metal millimeter part. Or if you want to do this as an inch part, select the inch sheet metal part. The first thing I'm going to do is set up a few global variables. So I'm going to go to the parameters box and I'm going to add a new numeric parameter, and I'm going to call this thread size. So I'll do thread underscore size, and I'm going to make that size 6 millimeters. Then I'll add another variable, and I'm going to name this one pitch, P-I-T-C-H, and I'll make the pitch 1 millimeter. I'll add another variable. I'm going to call this thread length. Do thread underscore length. And for my thread length, I'm going to do as 2 millimeters to start with, and we'll come back and change that later. And I'm add another variable. I'm going to name this hole depth. And for the hole depth, I'll set that as 3 millimeters. And I didn't get that. So my pitch was 1 millimeter. My thread length, I want that to be 2 millimeters. And for my hole depth, I want that to be 3. And then I'll add another value, and I'm going to do this one as clearance. And I'm going to put 0.1 as my clearance value. So 0.1 is about the thickness of a standard sheet of notebook paper. And I'll add one more, and I'm going to call this one coil underscore height, coil height. And for the coil height, I'm going to make that a formula. So I'm going to say equal to the thread length plus the pitch. And we'll see why in a little bit. So I'll say done on that, and I've created some variables. Now I'm going to go to my sheet metal defaults, and I'm going to set my thickness for 5 millimeters thick. And then I will go to the top view, and I'm going to start a new sketch. And it really doesn't matter which plane that I start this on, but I'll start a new sketch on the top plane. And notice the origin point is automatically projected. It might be a good idea to turn off the automatic projection of the origin, because we'll have to delete that. But I'm going to leave it on for now. So I'm going to put a circle in, and I'll dimension this circle, and I'm going to do this circle, and the size of it isn't really critically important, just so long as it's bigger than my threaded hole. Let's say I'm going to make this diameter 14. I'll finish sketch, and then I'll do a face, and I'm going to flip this down in that direction, and then I'll go back to the top view, and I'll do a new sketch on the part face. And so I'll do a sketch, and I'm going to then draw a circle at the origin, and I'm going to dimension that. I'll do list parameters, and I'm going to dimension that as the thread size. And I'm going to turn on the parameters so that you can see those as I create those. So I'll go to expression, and let me make that text height bigger so that you can see that better. So I'll go to tools, application options. On the general tab, I'll increase that annotation scale, let's say to 2.5, make that text height a little bit bigger. Then I'm going to draw a line here vertically, about like that. And then I want to remove, though, the coincident constraint to the origin. So we can't have any constraints on this geometry, so that constrain it to a parent geometry. So I'm going to delete that projected constraint. So now our sketch is no longer constrained. We know that we've got the diameter in here. I'm going to do coincident, the midpoint of this line to this point. Now watch this circle when I do this. That circle moved a little bit, which is fine. I may want to eyeball that with the center point, but I actually don't want it constrained to the origin. So this is a time when you don't constrain to the origin. I'm purposely going to leave that off just a little bit so that we can keep track of that as we go along. So now I also want to remove the vertical constraint on this line. So I'll delete that constraint. I'm going to change all of this to construction. and I'll finish this sketch. Alright, I don't need to see that dimension visibility, so I'll turn off the dimension visibility, and I'm going to rename this sketch as placement sketch. Now, I forgot one important point, that this has to be a sketch center point. So I'm going to right click, I'll edit that sketch, and I'll select this point, and I can toggle that to a center point. So your first sketch for a punch tool always has to have a center point in the sketch. Okay, so now I have that center point, and I will then create a plane perpendicular to this face using this line. So I'll do a plane, I'll select this line, I'll select this face. It puts a plane perpendicular to that face. I don't need to see the geometry of the part for a little while, so I'm going to turn off the solid body, and I'll go around to the right side view, and I'm going to do a new sketch on this plane that we just made. And I think I just turned the visibility of the plane off. Let's do a new sketch on that plane, and then I'll project geometry, this line that we put in the placement sketch, and I don't need to see the placement sketch anymore, so I'll turn off the visibility of that placement sketch. Now there's a projected origin here that I don't want that projected origin, so I'm going to delete that. And actually there's a point there that we can just delete that point, and then we don't have our projected origin. I'll just turn off the visibility of that, but this line is projected from the placement sketch. I am then going to draw a line, and I'm going to do several construction lines. So I'm going to go ahead and toggle construction line as the active line type, and I'm going to draw a line up vertically about like that. And actually, if it puts a vertical constraint on there, I don't want any constraint, so I might just purposely put this at an angle and then do perpendicular between this line and this line. So I'm avoiding perpendicular or horizontal constraints when I make a punch tool. And then I'm going to do a rectangle, and I'll do it from this spot, from the end point of that line over about like that. And then I want to remove some of those constraints, so let's turn on those constraints. So I don't want those two lines to be perpendicular, so I'm going to delete. I don't want these two lines to be parallel, so I'll delete those, and I don't want this one to be horizontal, so I'll delete that one. These two lines, I do want those to be parallel. I'm going to draw a line from the midpoint of this line over to the midpoint of this line. I'll make this line perpendicular to either this one or to this one. So I'll do perpendicular this line to this line, and then I'm going to dimension this line, and I'll dimension that as the pitch. And then I'm going to drag one of these points down, and it might be easiest to turn off the constraints here. So if I drag that down, notice if I drag this, that what happens on this side of the line happens on the other side, but I want this line to be perpendicular to this line. So I'll do perpendicular, and if there was a horizontal on there, we'd have to delete that horizontal. Let's just click on that. And so if I click on this line, if there's any horizontal constraint on there, delete it. I want it perpendicular to that, and then I want it perpendicular to this line. So I'll do perpendicular between these two lines. And again, if I drag these corners now, we see how this shape acts, and I will dimension this line as the pitch divided by 8. Refer to your machinery's handbook if you're not familiar with thread nomenclature to see how I am coming up with the dimensions that I use. I'm going to add a coincident between this corner and this point down here, and then I'm going to dimension the angle between here, and I want that to be 60 degrees, so I'll put in 60. I don't want to show any extra decimal places, so I'll go to the tolerance, and I'll say 0 decimal places on that 60 degrees. So I'll turn off construction, I'll draw this line. I want to come out beyond this line, and I'll come down to here, and so I'll draw the line then to here, and then down to here. Alright, so I automatically got this line parallel to this one, which is what I want. You may need to add that parallel in here. And then I want parallel between this line and this line, parallel between this one and this one, and parallel between this one and this one. Alright, then we'll put some more dimensions on here. So I'm going to dimension the distance from here over to here, and I'll dimension that as 0.54127. This number is actually 5/8 of the distance from here to here. If I put in that reference dimension and multiplied it by 5/8, it would come out to several more decimal places. And I actually want to put in that dimension times, and let's get rid of the units. Let's put UL for unitless, times the pitch. Okay, so it should be this 5.4127 times the pitch, and then I'm going to put a clearance distance from here to here, and so if I made that 0, it's going to bring this line over to there. And actually I want to make this equal to, or I'll make this the clearance divided by 2. This is going to be on the diameter, so I'll do that one is divided by 2, and then I'm going to dimension from here to here as clearance. And again, if I make the clearance 0, it's going to bring this line down to here, and it'll bring this line over to here. So those are the dimensions for my cutting tool for the thread. Now I want to put in the dimensions for the hole itself. And so I'm going to draw a line from the midpoint of the projected line, and I'll come down vertically. I'm going to change this line to a center line type, and then I'm going to draw a line over from this midpoint of this line. I'll draw this over horizontally, and I actually forgot I don't want to put horizontal vertical constraints on here. So let's go back to this one. We see there's a vertical constraint on there. I'm going to delete that, and instead I'll do perpendicular. This line is perpendicular to this line, and this line is perpendicular to this line. I'll dimension the distance from this point to this center line, and I'm going to then put in the dimension as the thread size times 1.1. Now for this number, I just experimented until I saw a size that looked good no matter what size I make the thread, and so later we'll see how that gives us our lead in for the thread. Right, and then I will come down from this point, and I'll come down at an angle. I want to be careful that I don't get it parallel to one of these other lines, and then I'm going to come down, but I don't want vertical, and so I'll come over about like that, and then I'll come down here, and again make sure that it doesn't put a parallel constraint automatically to something else. So I want this line to be relative to this line, perpendicular, so I'll do perpendicular this line to this line, or parallel to this one, either one. And then I'll do coincident between this point and this point. I'm going to put in an angle between here and here of 45 degrees for my chamfer, and I only want to show that to 0 decimal places. And then a standard drill is 118 degrees included angle, or 59 degrees for half of the angle. So I'll put that in as 59, and again I'll go to tolerance and I'll set that as 0 decimal places. I'll then dimension the distance from here to here, and I'll do that as my hole depth. I'm going to draw a construction line from this point right here, from this point, and I want to allow some clearance for the thread, so I'm going to put it up to about here, and I'll drag this over here some, and I'll make this line perpendicular to this line, so I'll do perpendicular this line to this line, and then I'm going to dimension a clearance value between here and here, and I'm going to set that then equal to the clearance, and because this is going to be on a diameter for the hole, I'll do divided by 2. I have all of the dimensions in for my sketches. I want to verify that I don't have any horizontal or vertical constraints, so I'm going to turn on the visibility of my constraints and just verify that I don't see any horizontal, no vertical constraints. I need to make sure that I don't have the origin projected, because the origin is not going to go with this punch tool. And so I'll turn those off, and I think we've got everything ready to create some features. So I'll do finish sketch, and then I'll turn on the visibility of the solid body. Let's rename this sketch, and I'm going to call this profile sketch. And I will go to the 3D model tools, and I'll do revolve, and I'm going to cut my hole first, and so I'll cut it around that sketch center line. Okay, so there is my hole with the lead in, and then I will make that sketch visible again. And this time I'm going to do a coil feature, and I'll select my cutting tool, and then I'm going to set that to be around this axis. And you may need to flip the direction. If it's going up, flip it so that it's going in the correct direction. Make sure it's on cut, and then for the pitch I want that to be the variable pitch, and then for the height I want that to be the variable coil height, and we'll select OK. I'll turn off the visibility of my sketch, and so there we see our thread feature with the chamfer lead in. Now it comes to a dead stop, which might not be desirable. We might want a lead out on the other end of the thread, but for 3D printing that's probably not critical. It's a bit of work to put lead out on the other end of the threads, and that might cause the punch tool to fail in cases where we have a thread that goes all the way through the part. So I'm going to not put lead out on this end of the thread. You might want to change the color of the hole and the thread. As if I go to properties and I'm going to change that hole to a red color, you could use whatever color you want. And actually this color isn't going to transfer over with the punch tool, but it may make it easier at this point to see what we have. And so I'll go to the properties of this one, and I'll change that one to some other color and save often. We'll then go to the Manage tab, and I'm going to extract an iFeature, and I'll come over and select a placement sketch, and it found the placement sketch and the geometry that is children of that placement sketch. And then for the clearance I'll leave that variable in. For the coil height I don't want to edit that one. We'll do that as the thread depth, so I'm going to remove that one. And the reason I put that one in there is our threading tool starts outside of the part. I needed to add the distance of 1 pitch in order to get it the correct length into the part. And then the hole depth I'll leave that in. For the pitch I'll leave that in, and then for the thread length I'll leave that in, and the size. Some of these I want to put in some default values. So for the pitch, let's click here where it says none, and I'll click on this down arrow, and I'm going to do a list. And so I'll do 0.5 for the first one, and I'll add another one, and I'll do 0.6. So these are standard pitches for metric threads. 0.7 and 0.8 and 1 and 1.25, 1.5 and 1.75. And if you do some really large threads, you could put additional pitches in here. So I'll go ahead and say OK to that. And then for the thread size, I'm going to put that in as a list. And so I'm going to do a size 3, a 3.5, a 4, a 5, a 6, an 8, a 10, and a 12. And of course you could put additional sizes in if you want to go larger or smaller. I would hesitate on going smaller. Really small threads are difficult to tap. If you needed to run a tap into that, it's easy to break the taps. And then for the clearance, I'm going to do this as a range instead of a list. So I'll do range. So I have a default of 0.1. I'm going to say from 0 to 0.1, 0 being my minimum, and I'll say less than or equal to, so I did less than or equal to, and then the maximum I'll say 1.25. And of course you could adjust that to that 0.15. Alright, we'll save this. Notice it has only one position selection that is needed. You just have to select the sketch plane. You already have a sketch point that it will automatically pick up to place the punch feature. I'll do save. You need to make sure you put it either in a custom folder that you know where that location is at, that you specify in your project files, or you can put it in the punch folders. I've already done this once. I'm going to call this revision 1 so that I can keep track of it. I'll go ahead and save that, and I don't have that as my active project, but I'll go ahead and save it to that location. And so now it is ready to use. So if I start a new part file, in this case I'm going to do it as an inch part. It really doesn't matter what the units are. Our punch is metric units. If we wanted to create a inch unit punch, we would follow the same steps to do that again. So I'll go ahead and extrude this, and I'll then put a sketch. So we need a sketch point somewhere to locate our punch tool. Our part isn't a sheet metal part, so we temporarily convert it to a sheet metal part, and then we can use our punch. And I'm going to do this revision 1, the one that I just made, and we see that it automatically finds that hole, and then we go to the size and adjust it as needed. So we could put this on any face that we want. If I do a punch on this face, and we'll do a whole bunch of them, I'll finish that sketch and I'll do punch, and I'll get the tool that we just made, and so it finds all of those holes, and I'll say finish to that, and I can place all of those threaded features. And of course, if I want to edit those, I just edit the feature. And for the thread depth, if I want to change that, any of these variables, so for the hole depth, I'll change that, say, to 30, and for the thread or length, I'll change that to 20. And we'll say OK to that, and that will update all of our threads. Again, save often. Helix is computationally expensive. You're more likely to crash. It'll slow your machine down. So wait until you have finished everything else, and then put your threads in last. And so here we see our threaded holes in our part. I want to change a couple of properties on my punch tool, and so if I go to place the punch and I'll select, we see that the preview is this image right here, and particularly it has that work plane, and it's really hard to see what it is going to create. And so I'd like to create a better image for this, or something that might be easier to see. Open up the IDE file, that's the punch file, and then I'm going to change my background color to something else. And so I'll go to the tools, application options, and I'm going to change that background to presentation one color so that it has a white background. And then maybe I want to also make some changes to the parameters, so I'll go to the iFeature tab and I will select edit iFeature. And so maybe for the clearance I want to increase that range, and so instead of doing 0.15 is the maximum value, let's say that I want to put 0.2 as the maximum value. So apply to that, and then I'm going to right click at the top node of the browser, and I'm going to go to iProperties, and I will go to save, and I'm going to tell it to capture the active window that I have right now. So I'll do capture, and I'll say apply to that, and then close. And now when I go to place this iFeature or punch, and when I said that, I realized for some reason, even though I opened that up, it was a punch tool. I need to make sure that I check here again that I want this to be a sheet metal punch tool. And so I'll save that, and then we'll place this punch again. Now if I place my punch tool, we see the image has changed so that it might be more representative of putting in a thread. And then if I want to change the size of that, again, I can change the size to whatever size I need. And actually, let's put that to a 10 millimeter, and for the thread length we'll do that as 20 millimeters, and for the hole depth I'm going to do that as 30 millimeters. For the clearance I can change that to 0.2, and if I put it greater than what we put in the range, so if I try 0.3, notice it's red, and it tells me then that maximum value, it can be minimum 0, maximum 0.2, so it tells me what is wrong. And then I want to change to 1.75, and let's change this thread size to 12 millimeters. And we'll say OK to that, and so we see our threaded holes put into the part. If you would like the starter file and the punch file used in this demonstration in Inventor 2021 versions, send an email to the CADWhisperer at gmail.com with the subject thread punch.